More examples here. In this one, we have x's in multiple locations, so before I start trying to solve this, I want to combine all of my x's together. So that means I need to combine like terms. The 9x, and I'll call this a negative 5x, again changing the subtraction to addition here. So 9 minus 5 is 4, so this is 4x plus 4 on that side of the equation, and a 12 on the other side. So the two things that are being done to my x here, we're multiplying by 4, then we're adding 4. So I'll begin clearing stuff off by subtracting the 4. We get an 8 over here, 4x, so 8 equals 4x. To finish this up, I'll divide both sides by 4. We get 2 equals x. So x is 2 is the solution to that one. On this one, I'm multiplying by 4, then I'm subtracting 1.5. So to undo this, I will begin by adding 1.5. This gives me, 16.8 equals 4x. Then to finish this one up, I want to divide both sides by 4, giving me 4.2 equals x. Alright, in this one, you can see I have this negative here. I'm subtracting the term with the x in it. I would actually like to have this as addition, and I'd like to put that negative down there with the 4. I'm changing subtraction to addition as I have many times before, and I could put that negative wherever I'd like. I could put it up top in front of the whole fraction or just down below. And so I'm putting it down below so I can think of it specifically as taking x divided by negative 4 and then adding 7 to it. Again, this is all about trying to be strategic so that when I'm undoing these operations, I have fewer operations to undo. So the last thing that I did to my x was add 7, so the first thing I'll undo is subtracting 7. First operation that I'll do to undo that, adding 7, whatever. 5 minus 7 is negative 2, and we get x divided by negative 4 over here. So x divided by negative 4 is negative 2. I'm dividing by negative 4, so to undo this, I will multiply by negative 4. So negative 4 times negative 2 is positive 8. Over here, those cancel out. I end up with x equals 8. This was a strange enough problem that I think it's worthwhile checking. We get 5 equals 7 minus x over 4, except instead of x, I should be writing an 8. I'm checking to see if this is a true statement. 8 over 4, you can see, is 2. 5 equals 7 minus 2 is a true statement. So this one definitely was a lot easier to check than it might have otherwise appeared to be. It's the exact same question, or exact same idea when you have decimals floating around. I'm going to start by converting this to addition here, so I can see I'm taking the x times negative 0.2 and then adding 14.25. So to solve this, I want to start by subtracting 14.25. Oops, I don't want to say equals there. Subtracting 14.25, so I'll take my calculator and do 2.75 minus 14.25, which gives me a negative 11.5. Equals negative 0.2x. Alright, to get rid of the multiplying by negative 0.2, I will take and divide both sides by negative 0.2. Divide this number by negative 0.2, which gives me 57.5. That number seems a little weird, so let's check it. 2.75 question mark equals 14.25 minus 0.2 times 57.5. So this stuff right here, the right-hand side of this equation, I'm just going to plug into my calculator. And let me move it over so I can see what I'm typing. 14.25 minus 0.2 times 57.5. You can see we get 2.75. So even though there's all these weird decimals floating around, I can be very confident in my answer that it is 57.5. That confidence in your answer is invaluable in my opinion. Alright, in this one, you could take two separate operations to undo this. I could look at this as multiplying by 3 and then dividing by 4. So I'd undo this. I would unwrap the x by first multiplying by 5, then dividing by 3. That's one way to do it. Or I could look at this as 3/4 x equals negative 15. Let's do it both ways just to see what they look like. Equals negative 15. So starting, the first way I'm going to do it is multiplying both sides by 4. We get some cancellation here, giving us 3x equals negative 60. Then divide both sides by 3, rather, to get rid of the multiplying by 3, giving me x equals negative 20. So that's one way to do it. Alternatively, I could think of this as 3/4 x equals negative 15. To get rid of multiplying by 3/4, I would multiply by 4/3. That is, its reciprocal. That's what we get when we flip the fraction upside down. So I would say this stuff cancels out. I end up with x equals negative 15 times 4/3. And you can actually see that that's going to be the same thing because I'm going to be multiplying by 4 and dividing by 3. So negative 15 times 4 divided by 3, which is again negative 20.